Okay, looking at the C test, we're going to do 2A and 2B. I would put that in Y1. I'd put that in Y2 before I even did the question. I think it'd be useful throughout the entire question. So now that you do that, the question in A, where was it? Question in A, on what intervals is the velocity increasing, and when is the velocity increasing? There's two ways to do the question, literally two ways, and it really doesn't matter, but it does matter in how you write the explanation. If you look at the velocity, it's going up until that point, and then it's going down. So it's increasing from here to here. So you can use your maximum function, and you get, I want to say, let's make it t. That moment in time is 3.963. So velocity is increasing, and then the velocity is decreasing. Now, remember, philosophically, though, the way that we normally have answered this question in a calculus class is, when is f increasing? When its derivative is positive, right? So what you want to actually do here is go, oh, the acceleration's derivative. If you take the derivative of that, you get this. Now they give it to you, so you don't have to actually do the derivative, so that's nice. So what you want to realize here is then that that it's positive until here, then it's 0, and then it's negative, so right there. But these are exactly the same point. Now, that's the answer. Oh, sorry. The answer is on the interval because now this is where it's personal preference a little bit. You either have to say because the acceleration changes from positive to negative at that point, or the velocity is increasing and then decreasing at there. So you can say that you can either say because the acceleration is positive on that interval, or you can say because the gravity is increasing. It doesn't matter. They'll accept either one on the test. Now, the second question is kind of a fun question. You got two particles moving around, right? So the question is are they approaching each other? Are they going away from each other? Are they going the same direction left, same direction right? Now, the question eliminates two of them for you, which is nice. They're not going the same direction, they're going in opposite directions. Now, it depends. If they're going in opposite directions from each other, they could actually be going away, or they could be approaching each other. So how do I figure out which? I need four things to do, okay? So here's what I'm gonna do here. I'm gonna, I look and I notice that they tell us the position of R is 8. They tell it to us, I think they tell us that in part C. They tell us this in part C, and they tell us this in part D. Now, we did this calculation for Q in 2B, and then now you do have to go back and do this last calculation. You've got to put 3 into Y1, assuming you put that in Y1, and get that number out. Now look what's happening here. If I look at the graph of this, now how you write this out, or how you say it, gets a little complicated. So I actually drew a picture on this here. So at 3 seconds, the position of R was at 8, and the position of Q was at negative 1.490. Now we did that calculation earlier on. So here's Q. So Q is on the left of R. Now here's the thing. R's velocity is negative, so it's moving to the left. So it's moving towards Q. Q has a velocity that's positive. So what's actually important here isn't the number itself, but this is less than 0, this is bigger than 0. So this is positive, so they're moving towards each other. Now you could write that out with English, but I drew the picture, and I'm pretty sure they'll accept that on the test. But if you want to say it, you can say Q is to the left of R, and Q is moving to the right, and R is moving to the left, so they are approaching each other. You could actually write it out in a sentence if you wanted. Okay.